Okay, before we start this, we talked a lot about factoring, and factoring is the most important skill that you can have going into grade 11. 25% of the grade 11 course, no, more than that. 40% of the grade 11 course relies on you being able to factor. So if you can't factor, you're missing out on 40% of that course. Okay, and then when you get to grade 12, about 60% of grade 12 you're doing factoring. So you have to have this skill mastered. Okay, so before we factor, I need you to think about the 4 names of factoring that we've learned. Okay, so you might see a hint here. The one was called GCF. Greatest common factor. So that one, you're taking something common. You're taking something common out. That's that method. Take something common out. Okay, and then we have one that's called ST. Do you remember what ST might stand for in a simple trinomial? So a simple trinomial would have 3 parts, and it begins with a 1, x squared. Okay, so that was the simple trinomial. Recognize it. And then we had a complex trinomial. So what's the only difference between a simple and a complex trinomial? There's only one thing that's different on how does it look. So it still has the 3 parts, but what's the difference? You're going to have something x squared. Okay, so that's the difference between the two of them. You have a 1x squared in a simple, and then in a complex, now you have something x squared. And then there was one more style, and here's the abbreviation for it. D S, what do you think that would stand for? Difference of squares. So the difference means to subtract, and then you would have 2 items. So in that one you only have 2 things. It's not a trinomial. Okay, so recognizing it, so I could give you any random one and you should say, oh, that is for sure a difference of squares. That's a trinomial, it's a complex, you should be able to recognize. Okay, so I'm going to give you these examples. We're going to do them together. Okay, so I've told you that this is a GCF, okay, but I would like you to be able to recognize it. So I scan and I say, is there something common in all of the terms that are there? Each term would have a what in it? An x, right? So then you go x bracket, and since there was 2 terms, I should have 2 items inside the bracket. Okay, so here's what I'm going to do. X times what would get me x squared? X times x. X times what gets me minus 8x? Okay, and you can always multiply that, and then whatever you multiply should make this. x squared minus 8x. Okay, so now in this, I'm going to scan all three, and what could all three be divided by? So you can think about numbers and then letters. So go through the numbers. What's the biggest number that you could do? All of them you could divide by 5. What's the most letters you can take out? All of them at least have one x in them. And then that's it, right? You can't do a y because this one doesn't have any y's, so then you're done. So bracket, I'm going to do 3 things going on in there because there was 3 terms. Okay, and do the process. 5x times what gets you that? 5x times what? Okay, so I'll let you finish that out. Okay, and check your answer when you're done. See if we are matching. Okay, so then the next type here says the difference of squares. So you can see that the difference is the subtract. Okay, so I need 2 brackets. In the first position, you're going to say what times what is m squared? So m times m. And then you're going to say what times what is negative 64. So if I'm going to times 2 things and it's going to end up negative, what do I know? One of them is plus and one of them is negative. If you're going to times 2 things to be negative. And then what times what makes 64? 8 times 8. Okay, and it has to be the same thing because technically when you're foiling, if you can remember that process, this and this are making 0, which is why there's only 2 terms instead of 3. So they have to be the same thing with a plus minus. Okay, so same idea. Same thing, but a plus and a minus. So what do you want to have at the front to make the 4x6? Plus or minus, and then what at the last? So 10y7. Okay, so that's the difference of squares. 2 brackets, same with a plus minus, different. Okay, next, simple trinomials. So again, you can see why it's simple, because there's just a 1 squared. Okay, so give me 2 brackets. What times what gets me m squared? So now you can do m times m. What times what gets me negative 27, but I also have to now consider the middle. So what do I need to know about these numbers? What is the rule? Adds, yeah, and times. So I'm looking for those two numbers that multiply to this, but at the same time, I got to make sure that they're going to add up to this. Okay, before we essentially just added up to 0 in the middle. That's why we weren't considering that. So now I'm going to pick 9 times 3 as my 27, and I got to think about my pluses and minuses here. How do I get a negative 6? Yeah, so then I'm thinking, yep, that multiplies to negative 27 and adds. Okay, and you can check your answer by foiling, multiplying it out as well, right? Okay, so the next one, 2 brackets with an x and an x to get x squared. So you have to multiply to positive 12 and add to negative 8. So can you think of two numbers that would do that? Think about your signs. If it's a multiply to a positive, I already know both signs are whatever they are, they're the same. And then to add to negative, I'm going to have a negative and a negative. Okay, so then the harder one was the complex trinomial. Okay, so now we have a 3x squared, so this is a complex. So what we're going to do is create this process called what's the flow number. So first times the last is a positive 30. So what I'm going to do is look for multiples of 30. So 1 times 30, 2 times 15, 3 times 10. Is it divisible by 4? No. 5 times 6. So out of those, I'm looking for something to get me 11. And I'm trying to get a negative 11. So 5 and 6, if I do what kind of signs? 2 negatives. That would multiply to positive 30 like I wanted it to here, and it would add to negative 11. Okay, so now I'm going to talk about the F and the L separately. So what could I do to get the F? I could do 1x times 3x. That's the only option I have. What can I do to get myself a 10? I could do 1 times 10, or I could do 2 times 5. Okay, now it's the puzzle. I need to make a connection. What with a 5, and what partners with what for a 6? Make a partnership. What pair are you going to put with what pair? Over here a pair and over here a pair. Do you see a puzzle? Okay, so I'm going to use the 1, 3 partner with a 2, 5 because I can see 1x and 6x if I'm doing that partnership. Okay, so when I talk about the partnership, it's all about foiling. So we're going to do these brackets, and I'm going to put a 1x and 3x in there already. First times first has to make that. So that is the F. So the puzzle is really the O and the I of the foil. That's the puzzle part. So now you go back here. This is the 1x has to be put on the, with the 5. So the outsides are making a 5x. And then the 3x has to connect with a 2. So you can see those outside inside arcs making 5x and 6x. There we go. You can always check your answer if you FOIL it. Okay, you should never get these wrong because you're really strong at FOILing, multiplying. You should be able to do that and check your answer. Okay, so let's try one more of these. So flow number is negative 24. So again, I'm taking the first times the last. That's where I'm getting it from. So I'm going to list 124, 2 and 12, 3 and 8, 4 and 6. I am trying to get a negative 10 out of it, but this is a little bit tricky. I know it's not those. And I'm questioning which one of these sets is it, and it's all about the signs. I have to multiply to negative 24. So I know something specific about the signs. How do you multiply to a negative? One of these numbers is going to be a positive and one is going to be negative, right? So which set would get you to the negative 10, knowing that there's a plus and a minus involved in this? Okay, so this would have been a tricky question because some people might have picked the 4, 6 and done a negative, but then, hey, don't forget, that's not making a negative 24 if you do 2 negatives. So it was close, but the wrong pick. Okay, so give me your F options, give me your L options. So F has M and 8M as an option. It has 2M and 4M as an option. Okay, find your puzzle. You need some set to make a 2 and some set that makes a 12. Okay, 2, 12. Now it's about lining them up properly in your brackets. 2M, 4M, I just put in right away because I know that's first. Then I draw my loops here. So this is the outside and inside foil parts. 2 goes with a 1. And that's going to make a positive 2M. 4 put with a 3 to make a negative. Okay? Is it all coming back? It's flooding your brain here. Okay, just a couple more here, the same kind of ideas, but this one tricked a lot of people on the test. It was factor more than once. So you have to pick which style. That's the hardest part. What are you going to do? You have to say, am I going to GCF? Am I going to simple trinomial, complex, difference of squares? Does anybody have an answer for me what they would see on this first one? Some kind of style. One of those 4. GCF, yep. So what is it that you can take out of all of those terms? 6 out. There's 2 terms, so give me 2 swivels. 6 times what? 6 times what? Okay. Factor more than once. So my instructions are it should factor twice. So now what am I looking at? This little part is a what? It's a difference of squares now. Okay, so you need that 6. It can't just disappear. And then 2 brackets. How do you make this difference of squares? You should be doing a plus and a minus, right? And there, now it's factored. Okay. Next one. Recognize, recognize, recognize. What is the style? I can see a difference of squares in that. Do you see it? So 2 brackets. X squareds are in the front. Plus, minus. And then it would be a 9. Then what? Factor more than once, so we can go again with something. Do you recognize anything? Just this one is a difference of squares. This one is not a difference of squares because it has a plus. That's not a difference, that's a plus. So this one is actually not factorable. So it's not factorable, so I write it again. And by the way, why wouldn't it be factorable? Because if you wanted to create this to be 0, x squared would need to be a negative 9, which isn't possible. You can't square something to be negative. Not factorable. And then recognize, so x plus 3, x minus 3. Okay, I think that one on the test was like a 70% success rate. Okay, forgetting that this is the one that factored and that one was not factorable. Okay, and this last one, scan it. Which style do you want to start with? Was your answer to that GCF? There is something you could divide out of all 3 terms, which would be a 2. They're all divisible by 2. Okay, factor more than once. So now, looking at that, what do you see? You always got to say, what am I recognizing? Those 4 styles are always in my brain. I see something with just that part. So here I see a simple trinomial. So my brain would say, well, what multiplies to 60 and would add to be 4. Thinking of multiples of 60. 6 times 10. Okay, and then you have to bring down the 2 yet because it is included as a multiplier. Okay, so then the last part of this unit was solving. So solving just takes your factoring one more step. So now this was an expression. This is an equation equal to 0. Okay, so you look at it and you say, which style is that? So recognizing the styles still. So look at it and see, what style are you picking in words? Did you think GCF? Did you see something with that? So there's 2 items. What's the commonality in those 2 items? An M? So this time I'm also writing equals 0 at the end. I can't forget that. It's an equation now. Okay, so there's 2 multipliers, and I'm trying to make each multiplier 0. So if I wanted the first multiplier to equal 0, M would have to equal 0. And then if I wanted the second multiplier to be 0, M would have to be positive 9, because 9 minus 9 is 0. Okay, and then number 2, style. Should recognize it quicker and quicker every time. What style? I would see a, did you see a difference of squares in that one? So 2 brackets, plus, minus. So don't forget, equals 0 at the end of it. So now the final answer is, what kind of value does x need to be to make our multiplier 0? So this one, x would have to be a -8 to be 0 in the whole bracket, and positive 8. Okay, 2 more to go. This one is a, did you recognize? Simple trinomial style. 3 items. There's a 1x squared. So simple trinomials are xx. What multiplies? I need multiples of 20. And then you're trying to make a 1 with those 2 numbers. Multiples of 20. Would you pick 4 times 5 to get to 20? 1's going to be plus, 1's going to be minus, and you have to make a -1. You have to make a -1. So what are the numbers that cause the multiples to be 0? A -4 and a +5. Okay, so the last one, you guess what I gave you? I gave you a, so this would be the hardest one, a complex trinomial. Okay, so we're going to go flow number. So 12, -5, that would be -60. Does anybody have a multiple set of 60 that could make 28 before I list them all? Did anybody think of a set? 2 times 30 makes 60. And this negative means there's something negative and something positive. So 2 times 30 is 60, and that would get me a 28. Okay, F, L. list all your separate options. There's a few options for F, but only one option for L, right? Okay, remember what you're doing. You're looking for puzzle pieces, partners that make a 2 and a 30. 2 and a 30 partnership. Can you piece something with each other? Okay, I found a set that's going to make me a 2 and a 30 somehow. So it's all about lining it up. Okay, so I'm going to put 2x, 6x in there already because that's my first. So there's that, F. I got it, first times first. Now I'm going to talk about the outside and inside. Outside and inside, and then I'm going to make my connections, making sure they're all in the right spots. So 2x needs to connect with a 1. That's making my negative 2x. And the 6x needs to connect with a 5 to make a 30x. So you can see my outsides and my insides are together making the 28x. That's what they're doing together. And then that just works out. There's the negative 5 at the end. Okay, so when you answer this, what is the actual answer that makes that 0? This is going to be a fraction. Do you remember how to do it? Opposite divide. Opposite divide, how do you write that? -5 over 2. And then if you don't remember where it was coming from, all I'm doing is I'm just saying, well, how do I get this to be 0? What's the algebra? -5 divide by 2. So it's always like that, opposite divide, because that's all you're doing every time. The algebra, move, divide. So if I think of that, what's the little trick on this? Move, divide. And that was your foundation to all your factoring that we did in September in Unit 1. Okay, I didn't go over some of this stuff. Actually, no, it's fine. Let's see. Okay, maybe I'll just wait till tomorrow for that.